Hello and welcome to the Visual Analytics webinar series. Today is a pretty exciting session because we will have both a Tableau Zen Master and a data scientist sharing best practices when it comes to visualizing data science. A few notes before we get started. This session is being recorded and the recording will be made available and emailed to you in the next day or so. We will also be taking questions and answers and answering those along the way. So be sure to use the Q&A icon that is found at the bottom right of your Zoom panel to plug in your questions. I'll be monitoring those as we go along. So feel free as they come up to go ahead and type them in. A few introductions. My name is Rachel Mason. I'm the marketing specialist here at Teknion, helping out with this webinar series. And be sure to check out our other exciting 3 series that we have going on. Along with visual analytics, we have data science, data strategy. So be sure to check out upcoming sessions. And with that, I'm going to turn it over to Bridget Cogley and Kyle Roberts.
Thank you for joining us. So today we are presenting on data science, and without further ado, some of our goals today are really to demystify the black box that's typically associated with data science. We'll do this by leveraging tools like Data Robot and that allow us to have techniques that really showcase this visibility. The final piece, and a lot of this is really going to culminate up to it, is really explaining so that as we look at ground truth and machine learning and these predictive algorithms, we make it so that they can work together. So when we start talking about communicating with data science, I'm going to turn it over to Kyle a little bit to talk about some of these features that are typically associated with Data Robot, but he'll also discuss a little bit of how you can get some of this information from other tools.
So good, thanks, Bridget. And so yeah, Kyle Robertson. I'm a data scientist here with Teknion, and wanted to start with this because I mean this kind of jokingly, but I'm serious about this too. When Rachel first started off and said, "Hey, we have a Zen master and a data scientist," both of those things could be said about Bridget. And let me give a little caveat on that. The reason I bring this up is because I think that this should always be a piece of data science. Is when you're moving into visualization of complicated thought and complicated stat methods, you've got to have that visualization piece. And this, I used to teach my students this also, is that when you are, if you're a I used to teach stats at a university, and when I was teaching there, I would always tell my quantitative stat students, hey, you need to be really good friends with a qualitative researcher also, a good qualitative researcher. Because as a statistician or as a data scientist, a lot of times you come in with the idea of okay, what do the numbers say and kind of what are they telling, and I'm trying to answer a specific question. But even more important to that is how do we communicate the results of those stat runs or those different models and how they fit. And so in that sense, this is data visualization is data science also. It's data, a lot of times we'll think of, okay, data science is the just running the model or something like that, or the data prep for the model, or getting it. This is just as important. And the reason I love this is that what we're going to talk about today, because I think Bridget's going to show you something you've never seen before, where we're going to take something that's ridiculously complicated, and we on purpose are picking a really hard model that we're going to put together and then talk about what is it that we feel like it needs to be done in order to communicate this to not just say someone who has a strong stat background, but the end user. Because if it is true that 95% of all models don't get deployed, we think that part of the reason they don't get deployed is because people just don't know how to visualize what the results are going to be from those. So this is the, it's not a yin and yang. I mean, we think of qualitative and quantitative as being kind of at odds with each other. They're not. They complement each other very well. We shouldn't think of, and again, I'll push even further, we shouldn't think of data science and visualization as being two different things. they're both important aspects of, I would call both of them are data science. Now we can't do data science without visualization, and you can do visualization without data science. But to me, they're both kind of, they fit under the same umbrella. And so what we're going to talk about today is what's called a next best offer model. And I don't want to get too into the weeds in this, but for those of you who have heard that before, man, this is a incredibly complicated stat method. And again, we chose it on purpose. Because what you're trying to do is you're basically taking a bunch of data from a bunch of users, and you're trying to figure out, okay, when I have someone on the phone in a marketing campaign or something like that, when I have them on the phone, what is the next best offer that I could make to them, and what's the probability that they will respond to that offer? And so it's really kind of doing almost a real-time prediction. We're saying, all right, I've got somebody on the phone, here's their profile, here's the parts of the marketing department that they are, the products that we offer that they have, based on all their profile and all the things that they currently have, what should I market to them next, and what's the probability associated with that? So we're going to look at things like feature impact, and you see that here. The feature impact that we're going to see is really related to how that, which variables we think contribute more to our model, and which variables we think pull in actually are not as important in our model. We need to seriously consider the model blueprint, meaning how do we get to a prediction? Like, where do these variables sit and how do they inform our prediction? And then on this one, because we are doing this isn't a regression type model, this is what we would call a classification. So we're trying to say, all right, which is the next offering? In this case, we're going to have 5 offerings. Which of these 5 offerings should come next? And so we want to look at something called a confusion matrix that is really us looking at, based on our model, how well are we doing, or how good are we doing at predicting, hey, this is the type of, based on what a person has, here's how we would understand what they would be available for in the future. And so these 3 things, this is where Bridget and I went back and forth and back and forth and back and forth. So I built a model and I'm like, all right, I feel good about this model. All right, Bridget, let me pass this off to you, and then let's talk through this. Okay, so first thing, we talk to the model blueprint, like what's going on, what's actually happening, which features are important, and then on to the confusion matrix after that. So then this last part of all right, this is where we spend a lot of time, because for us, we kind of came down to in talking, and Bridget, I'm curious as to kind of your feedback on this one, because really I think this is where we spent the bulk of our time, because for me, this was the thing that tells me, is my model good? And it seemed like for you, this was the thing that was able to translate into, okay, how can I use this type of analysis to inform future models? And so I'm going to push it back to you, Bridget, and kind of your thoughts on us iterating back and forth on what's useful, how can we use it, and then how that's going to inform what you're going to do visually with the output that we had.
So for me in particular, this confusion matrix ended up being absolutely critical to understanding. When we're typically doing descriptive analysis, we can easily see the pattern. We can easily kind of go through and say, oh, it's this or this or this. And I mean, even Tableau's got a lot of this built into it now, where you can use explain data and start picking up on some of these signals. With this confusion matrix, it actually highlighted a key part of the problem. And I'll actually revisit this when we start looking at the visualization. And I ended up recreating this graph exactly to begin to understand the pattern, to begin to figure out where I was going awry. So I had a lot of different data sets, and I'll go through those too, but this confusion matrix, you know, when you think about very traditional stats, you've got p-values, you've got kind of some confidence, and it's like, okay, and so when I see some of these numbers, I mean, from a like traditional, hey, I expect 95 or better, and some of these numbers are like 57, you know, that to me was like, whoa, but you've got to look at the whole picture. And so that was kind of my piece with this, was really kind of going through this, understanding where the model is getting confused, and really being able to defend it almost as I went through my exploration. So that was, this was definitely a critical piece. You'll actually see this revisited in a couple of different ways. And I'm going to talk about probably one of the biggest confounders I ran into as I was visualizing this data. And I was ripping my hair out over this one particular thing because it frankly didn't add up in a descriptive view. But when you look at it from a prescriptive standpoint, and you know to kind of redirect to certain other things, it's much more helpful. So you'll see this come up multiple times. And to me, some of this is the validation of said data, so how well it goes through the model, but it's also a checking myself and checking my own analytical loop as I go through how do I visualize this and make this accessible to other human beings.
So Bridget, I want to jump back in just for one more comment. And this is because I imagine more of the people who signed up for this class, for this webinar, are more interested in visual analytics than the stats back end side. And so let me start with this. Us quantitative statisticians, we may be the most arrogant group on the planet, right? Please don't, that's, Bridget's really kind to me, but we're an arrogant bunch. Maybe a little bit, just barely under like cardiologists, okay? And so the struggle is that I think there will be times that when you're working with a quant person, is that they're like, okay, look, here's the data, here's the results, make it pretty. And that wasn't the way you and I interacted at all. I mean, we went back and forth a lot. So maybe it's worthwhile saying, like, here are the things I wish Kyle had done better when we talked, or did that go well, or what about it went well? And maybe you could speak to, hey, here's the frustration with when you're doing this in future with other statisticians or technical data science people. Here are the frustrations you're going to have, and here's how you're going to get through that.
So for me, it really went down to I needed to put a lot of this into Tableau. So some of it was getting the data. The data was really disparate. So I'll jump back to kind of how I shaped the data later. But this was a critical visualization of my learning path. This was by far not the final visualization, but this is the visualization I needed to make sense. And so you see terms like model precision and standard deviation, and here's the cross-validation scores and client distribution. None of this is human friendly ultimately. I mean, this is very deep in the weeds. For me, it was really easy working with you because you were very open. So I could come back to you multiple times with questions and say, hey, this isn't making sense. Does this line up with what you would expect? We had a lot of those discussions about, like, is this what you would expect, or why is it doing this? And so, you know, I had to, we did a lot of back and forth of like, why this, why do you think it's doing this? Why, you know, does this from a gut check make sense? And so, I mean, you see we're relying on both the learned understanding, but also a level of intuition. And so this was a learning biz for me. And so some of it was just trying to see the pattern. Again, when we do descriptive visualization, we're used to being able to see a pattern. You'll see over here on the very far bottom right where I've got, I mean, it almost looks like UPC codes where you can really barely catch out a pattern. And so it's like, why is it doing this? And so, okay, number of voicemails may be a factor into why it recommends voicemail. But you'll notice a lot of this very top of the area isn't shaded blue. So, you know, some of these high voicemail users are not being recommended the voicemail plan. And so it seems counterintuitive. And so we'll talk a bit about ground truth. And we learn to process information in a certain way, typically through ground truth, through our own experience. And even the scientific method is meant to extend our experience, not replace it. And so when we do this and these things don't add up, we need to know why. And so eventually I figured out why, but it was definitely a journey, it was a struggle, and even still the answer is not wholly complete.
But I will add, it was fun. Like for me, us going back and forth on this, like it was a lot of fun because I was going, oh, I never thought about it that way, because I tend to think, and I'm very well, I'm actually really hard-headed. But then when I see these vizzes, and again, to the idea of, you built a viz just so we could build another viz. I mean, I'm like, golly, I would never do that because I'm just too impatient.
Well, and that would, I would say that's probably one of the key parts about data science is it's not a linear path. And so too often it's really, really easy to say, hey, I'm going to go in, I'm going to prep the data, I'm going to look at all the data sources, and voila. Well, the problem with that, though, is we've got these 4 different data sources. So here's my raw data that I'm used to working with. We've got these prediction data sets, and as Kyle mentioned, it's a predictive data set, but it's also multi-class. And so if I jump into this prediction data set, I want to call out 2 things that, it took me even a little bit to figure out. And it's like, oh, hey, here's, my 5 scores. And so there is no, text prediction. This is the prediction. And then if you tally them up, they equal 1. So you kind of get a feel of, okay, they distribute across this. This gives me kind of a rough score. But if I want more information, I'm going to have to do a level of calculation. The other thing I had to kind of get over was this hump of cross-validation. And so that's where we go back to that confusion matrix. This cross-validation was critical because it partitions out the data, it tests its hypothesis. So it's going through, it's making this model, and it's progressively tweaking it. And so these cross-validation scores really show you how accurate it's getting. Okay, it thought this is kind of the variables it put, here's the end result. These are the variables it put, here's the end result. And so when you recreate that confusion matrix, you can't just throw in all these values and expect it to match. You have to pull out the holdout. You have to use the appropriate filters. And so that was kind of a learning of, okay, here's these line up to this particular item, but that partitioning was key. And so this is what my prep flow looked like. I would show it to you live, but unfortunately, because I'm sharing over Zoom, prep has decided it's going to show nothing at this exact moment. But this gives you an idea of the amount and complexity of just pulling in this data and making it so that I could get even a cohesive story. So my data, when you shape it for data science and you shape it for making models, you really make this very wide data set, and that's not useful in Tableau. So I had to refactor it to things like call, charge, and minutes so that I could get a more human-centric story and a business use case there. But then I had to pull in some of these predictions, and you see where I had to say, okay, what is the top prediction? So I could actually get a text and say, okay, top prediction is going to be daytime plan. Top prediction is going to be this. And so that way I could make something meaningful within the first part of the data set. Then I needed to make kind of a more explainable AI data set. So really explaining what was going on with the machine. And so that took a lot of work, really thinking about it. I made multiple different data sets to really tell that story, and I failed multiple times in this process. I had a lot of theories, and I was like, hey, maybe this will work. And it worked for me, but it didn't ultimately work for the use case. And the use case is, hey, we need to make something to deploy. Let's say we're working in a call center, and we're going back to the 2000s where night plans were a thing. But, we need to make an actual dashboard for people to use. And so this ended up being the dashboard. You'll notice that I ended up bringing in this recommendation rationale. And you'll notice how the terminology changed drastically. So instead of it being things like model and things like that, I've got factors and weights and decision. So I really took the register of that down. I've got things like, here's the actual value, so you can visually see kind of the dispersion. So this is a little bit more of the way we're used to looking at things. I've got this indexed value, which really kind of gives you a visual percentile and ranking, so you can really see where people fall and distribute in this decision-making matrix. But then you can also kind of see what's the likelihood of accepting a particular plan. So you've got a lot of conventional knowledge. You've got a lot of very strong cueing of here's how to use it. Particularly from a visual side, that really making it easier, and so that if this is a product, this is being rolled out, I'm defending it. I'm making it so that you can trust it, so that as I present this to you, it doesn't feel like I just threw it in a box, shook it up, and pulled out a ticket, but that there is a rhyme and reason. It may not be as explicitly clear as I would like in, say, a descriptive dashboard, but we are dealing with predictive. And so there is a lot of nuance. So for me, as I was working through this, one thing I kept running into was the realization that the daytime plan is probably, you know, one of the worst results, if you will. So if I was trying to make sense of anything with a daytime plan, I kind of had to reorder it and had to reorder my thinking. I had to look and say, okay, you know, enhanced voicemail plan, international plan, these are a bit more accurate. And even call evening plan, you know, that's a bit more accurate versus this daytime, well, a bunch of things fell in it, it wasn't nearly as accurate. So that was something that when I was going from a descriptive side and doing my exploration, I kept running into this daytime doesn't make sense. And the reason is because it's not the primary one. You want to start on some of these others first and then work your way down. And so that really helped lend some clarity because again, I'm looking at total evening charge, I'm looking at international minutes, evening minutes, then day calls. So you see how these three items really get a bit more heavier weighted than some of these daytime calls. Kyle, do you want to jump in?
Sorry, yeah. So
maybe before Kyle speaks real quick, we do have one question. How do you make a confusion matrix in Tableau? And it says, I haven't seen this done in Tableau and would appreciate a starting point. So if you guys have any recommendations on starting points.
So what I ended up doing is I had to factor my data set to do so. So you'll notice I'm not basing it off of my business presentation data set. I'm basing it off of this explainable AI features. And so one critical part to that was the data shaping. So you can see here, this is my prep flow. You can see, unfortunately, the data decided to drop out today, but what you can see that's really critical is how I pivot these features. So I take every single feature here, I pivot it, so that way I can line it up with my feature matrix. And so I can actually see client by client where they fall, but then you can see I've also pulled in other kind of mixed grains. And so from there, what I'm doing is I'm saying, okay, of the actual offering, so here's what was offered, versus here's the prediction. And so this is where I had to go through and ultimately calculate this out in prep. So that's where I had that whole matrix of here's the 5 different, you know, predictive classifications, pick this one. I didn't have to do any tiebreaker logic because I didn't run into any ties, but if there is a tie, that's something to consider as well. But again, I built this so that you could kind of see this, and then I tallied up where the predictions landed. The other thing too that ended up being critical was putting in the partitions. So really saying, okay, this is, you know, the holdout and applying that. But then the other piece that I did with that was really making sure that as I submitted it through here, that it provided some information here. So I found this graphics. This is actually just a noun project icon, and then I've got text over it. And then I provided some cueing text to really help people navigate what in the world is this telling me. And then rather than using a traditional action filter, I am using set actions so that if I click down here on no action, I'm not necessarily reporting the accuracy of this. What I'm reporting is still the model precision for that column. So that was kind of a choice I made. It may or may not be the right one, but that was the one that I felt made the most sense in presenting this. Because I wanted to focus on when it got it right and less on, hey, this is where it's wrong, just to really help people navigate it. And then if I wanted to, I can definitely provide this in Tooltips. So I do have an iteration, I think, where that was a little bit more explicit. So you can see here, again, just navigating and putting in tooltips and things like that to really convey what's going on. Did that answer the question?
I think so. Thanks, Bridget.
all right, so I'd love to talk about, and because for me, this was a one of the things that Bridget brought out. And yeah, if we can see actually that one, please, Bridget, the one you're over. Yeah, there we go. Was this idea of this is where Bridget shaped the way that I think. how do these variables contribute to our model? And so what I'm talking about this is this recommendation rationale that she had on the right. Is that, and the reason I thought that this was really important, and when she started pulling it out, oddly enough, I kind of fought her on this one at first, because she's pulling this out, and I was saying, I don't know that that's necessarily a good idea, because really you think of variables in terms of the holistic nature of the variable. But here's where she won me over on this, is that when we are selecting, in this case, client number 16, okay, when we are selecting that client, what I immediately see is a profile for that person that I would not have looked at before, because I really only wanted to consider all of the data in building a model. And so, and here's why this was important to me to move outside of the way I think on this. And this is where now the visualization has informed the data science into a new way of thinking, okay? What Bridget has done is giving you in this visualization actually two different things. Yeah, we want to make the offer for, there's their next offer is enhanced voicemail plan. But let's suppose after the fact, I wanted to say to my marketing department, hey, if we're trying to get more enhanced voicemail plans, if that's our target, what does that profile of person look like? And so with this visualization, I don't even need to run a profile analysis, right? Which is something that would be a totally different model. This is the model that's now based on different clients that we're seeing that are, the enhanced voicemail plan. I can look at this profile on the right, or even this profile kind of that's above there. And on this, I can see, look, these people, they tend to have higher evening charges. They tend to have lower minutes. And so now I'm starting to get information that is now informing, not only is this predictive of what they're going to do, but it's also prescriptive for my marketing department. Now, by her including this piece in here, she went beyond what the original intent of the model that I built was. And so now I've got more information to be able to go back to, again, marketing and say, hey, if you're looking to start making offerings to these people, why don't we start playing around with this? So yeah, the enhanced voicemail, we can drag those up and down, and then watch how these profile plots on the right change. This is going to give you a lot more information. So for the ideal person, yep, there you go. Exactly. Thank you, Bridget. That's exactly what I was thinking. All right. So the person kind of at the top of that prediction for the enhanced voicemail plan, what do they look like? And so really what you're seeing is that, boy, they're having a lot of evening charges, and then they're really high on evening minutes, okay? Day calls, which tended to be less important, but as I cycle down through all these, we're now painting a picture for the rest of our group to be able to go, okay, here's what this one looks like. Now, if we wanted to, we could even take this a bit further and create a whole new dashboard in this and go, okay, take all the people who are high in enhanced voicemail and let's kind of produce averages for them on these if we wanted to take that to that next level. But all the information's already there, and I never would have thought of doing this if Bridget hadn't gone, here's what I want to, this makes more sense to me to look at these types of things. And so that's where now the visualization informs the data science. And this is something, again, because we iterated back and forth, and because I didn't go to Bridget and go, no, it has to look like this, right? Now we've got a better product. But again, you're going to require when you're doing that yourself, this is going to require a bit of humility on that part of the data scientist. And unfortunately, that doesn't come very lightly. I mean, it's tough to work with data science. Are going to go, you're probably going to find out more about this than I originally gave you. And so that is that's a very real struggle. I think some of you are going to find out there. But when you see things like this that Bridget produced, now you go, okay, this is working in harmony really, really well. So.
And for me, it feels like there is this fear of, if I poke the model too hard, maybe it'll break. And so there's a little bit of working around the like, well, what I'm trying to do is work between ground truths. So, you know, if I'm working as a salesperson and I'm selling these, anecdotally, I know things. And so if anecdotally the model doesn't line up with what I know, then I'm going to fight it. And that model long-term will fail because yes, you may recommend this, but I may say, yeah, I don't trust it. It really should be this, you know. Trust is critical, and so that to me is really the value behind this. And so for me, I was really insistent on, I need to expose this, but moreover, I need it to make a level of sense. It won't make perfect sense, but I need to make a level of sense. So as I look through these things, when it recommends things that don't feel right, I at least need to be able to kind of look and say, okay, well, you know, these things get weighted higher, these things get weighted lower. You know, anecdotally, I'm used to looking at this bar chart area and saying, okay, well, you know, hey, their daytime minutes are really high, and, you know, international whoop-de-doo, they're only making a few calls. But, you know, maybe these charges, you see how outsized these charges are. That's not something that at this small of a grain I'm sensitive to. So that's something to consider as well is, you know, what is it exposing? What is it not exposing? You know, and two, I really first started here because what I needed was, okay, you know, as I look at, you know, all of voicemails, so kind of talking about that profile, this was my aggregated profile, and looking through this and kind of saying, okay, well, this, you know, okay, I see the distributions here, I see, you know, this, but this just looks like noise. And so what else am I missing? You know, and so some of it's at the individual level, some of it is, you know, working between these two items. And I personally needed both. I needed this model explanation to really start to say, okay, well, this dips out, you know, and as I look at evening plan makes more sense. Daytime plan makes no sense. International plan starts to make sense when you look at that other view. And then enhanced voicemail, you know, also makes some sense. But again, you can see where, you know, I've got some level of aggregation, but not everything makes sense. But again, that's where you need that mix of here's the high level, but here's the individual low level, and why that individual at that time. And it could be too that that individual's down here. So as you get to some of these lower likelihoods, you can really see that your data gets a little bit more different, a little less skewed typically. And particularly when you start digging into daytime, it's definitely a little less clear. This one's clearer, but.
And so, which often brings up a really interesting question. And so I'm going to talk just for a minute about statistical theory, but don't drown me out, or don't use this time to go to the bathroom. I promise it's worth it. Okay. So in statistical theory, one of the things we do is we always say the model is true. Do my data support the model? Okay. And we never say, we would never come to a point where we say this data support the model. What we generally end up with is well, not generally, what we 100% of the time end up with is we say, I don't have data that would lead me to reject this model. So in other words, I'm going to fail to reject this model. I'm going to say this model actually seems to work, or this data seems to support this model. But it never supports it 100%, like never, ever supports it 100%. It's just what you're doing is you're saying, all right, I like this, the data support this model enough that I can say, yeah, I can't reject the thought that this model might be true. Okay, you're never saying 100%, but what it is you're saying, all right, I see enough data here to say I can't reject that idea, okay, that the model is true. But we know it's not 100%. And so there's always this aspect of, like, you shouldn't get from a data scientist that, man, this data, this is the model and the model is true. No, the model always fails at some point. Now, what Bridget's done with her visualization here is she's tried to give you an idea of when will the model fail, or when does it not work, or for what types of people does it not work. And this whole daytime plan thing that she brought out in here was massive, right? You wouldn't have seen this otherwise. So go ahead, Bridget. Yeah.
for me, it really boils down to, is this better than a coin flip? Because typically we do make decisions based on coin flipping. It's just, okay, I think this, and it really is that, so does the model perform better than a gut check? And, that's the ideal. And that's kind of why, from a visual standpoint, 62 seems low, but, that's definitely better than a coin flip. And even 57 is better than a coin flip. And so that's kind of the other part of how do you build trust is, letting people know when it's going to fail. So daytime, you're not as likely to be successful on these daytime plans sales. You're just not. But you can start to maybe trust the pattern a bit more on some of these other items. And the nice part is, as you continue to use this and as you can continue to get data, you can include in your reporting how it's doing over time so that people can see kind of that investment of trust. What does that look like as we use this? And we're continuing to refine that model, because that's the other part of this, is that they do continue to refine as they're used.
All right, so let me ask you a question, Bridget, but that I'm sure everyone is wanting to know. Well, actually two questions. The one is I'm sure it's going to come up. How the heck did you build this? This is incredible. And so we'll come. I think we could come back to that one. But the other one is like, how do I build a culture of really trust between the people who are doing the data visualization and people who are doing the data analytics, meaning like the quant part of this? How do we start to bridge those gaps? How do I create a culture like that, like you and I have at their own place of work?
So one thing I think is absolutely fundamental is respect. And I think you've done a fantastic job of modeling that culture of respect, where, we initially advertised this as a Zen master and a data scientist. And you're like, no, there's two data scientists in the room. And as horrible as it sounds, I do think these labels matter. So I think that's a part of it, is that, you identify as a team. And so it really does go to that identity question of, naming it, identifying as a group, not being afraid to ask questions, and really normalizing I'm not asking you because I think you're doing a bad job. I'm asking you so that I understand, so that I can then take that understanding and help others. So effectively, I'm acting as the interpreter in this room, where I'm going to take what you say, mirror it to a language that's more accessible to others. So it's a bit of that working together and realizing, the goal is this, you did this part, I'm going to take this part, but we're still hand in hand. It's not just you throw it over the fence and run away, but that really there is no fence. We are part of a team. And so I really tend to use more of that medical model, where you have a surgeon, you have an anesthesiologist, and while different people may play different parts during the surgery, everybody's in the room at the same time, and you don't want anybody running out of the room.
I think that's well said. And I think, too, a good analogy that works here is I travel a lot overseas doing mission work, and often I have a translator who's there with me. And I love that you said the idea of translator. The first thing I always do when I have a translator is we have a conversation. I say, look, if I use some colloquialism like chicken fried steak and cream gravy because I'm from Texas and y'all don't know what that means, stop me. Right? Just stop me right there, and you have a sidebar with me and say, all right, that doesn't translate. I don't even know what that is, right? And I think the problem is with us as the quant people, is that sometimes we assume that everybody understands what we mean by, and your point before was really good when you said, man, when I started looking at these cross-validation values, like, I didn't know what that was. Well, okay, so we needed to have conversations about that. And I didn't think that is a threat to my model, because you're the one that has to interpret it, right? Bridget is. And so that's again, is for the data scientists or the quant data scientists that are on here, that's the attitude you need to have when someone's doing a visualization of what you've done, is they're my translator. I need to make sure I don't use a colloquialism that no one's going to understand when it comes to data. And that's what we were really good at, that of going back and forth, and you going, okay, I don't like this. There's something here that doesn't sit right. Good. If it doesn't sit right with you, it won't sit right with anybody else. Yeah.
It was definitely, you know, so to me that conversation was key. The trust was key. We've had a good relationship, so I think that was key. I think you knew I wasn't trying to do anything horrible or blow holes into your model. And I do think there is a level of fear of you build these things, and then sometimes there is a level of, well, it did it on its own. And it's like, okay, but, you know, what can we expose of this? You know, how do we articulate what model it's choosing? What does that model visually look like? That to me is where that blueprint really came in handy, as I look at, you know, how does it shape the data and what is it thinking about when it does the, you know, these categories, you know, so I see it's breaking out, I've got categorical versus numeric, you know, it's encoding certain things, it's making numbers out of these, we're doing gradient boosted, and hey, look, here's a prediction. So I can see that these different items are handled differently. I can look at this feature impact. And so, you know, where is this coming from? You know, and you can look through, you know, here's some of these different pieces where they get, you see this really steady drop off. So here's some of the most important things, boom, boom, boom. And just really playing with how these things shape out. That was critical to me. And then again, that finding of, yeah, hey, there's a lot of values in daytime, but it's not that precise. That was really critical to me. So I joke that we've written all these books now on doing data science, and so it's, you know, here, awesome guide here, and but digging into data science, I mean, I definitely felt like the bird, like digging for each little seed and then validating. It's like, hey, flying in the dark, but you know, that definitely got us somewhere really compelling. And so I think the other question you originally had was, how do you design something this awesome? And I want to go back to this blue one. So I really started in blue. You'll notice too, I don't have a lot of color in my work, and that is very, very intentional. So I want the focus to be on the shape of the data and not so much on 9,000 colors. And so as you look throughout my body of work, you'll see this over and over again. And you'll see we morphed from this very white and blue to a black. And some of that's because Data Robot itself is in this black palette. And I chose this like kind of dark futuristic blue, again, in part just to reinforce the brand. But I needed a color to fall away, not be distracting, that would work with some of these very bright colors. And so these are all colors I found within Data Robot, and I pulled them in and said, hey, we're going to use these. And then a lot of this follows a very traditional analytical path. So you've got, you know, here's about your customer, here's the contract itself, these are the activities. So this kind of gives me a very visual representation. And then this kind of, you know, bar chart reporting just gives me an idea of how these things fall. So really kind of sensing these patterns, hey, here's daytime, but, you know, I may have more nighttime minutes, more calls here. And then, you know, here's how the charges fall out. And again, I wanted this to be to where you could kind of do a visual exploration. And so I was also trying to think purpose driven. So, you know, if I'm an agent in a call center, somebody calls in, I can manually look them up. And that's not going to be a valid number, but I can manually say, okay, I want, you know, client number 1. And I can get to that person and exit out of that and start going from there. Or if I'm doing cold calling and I'm working my way through, hey, we've got this promo on an international plan, I'm going to click through one by one. But it was very purpose driven. You wouldn't do a data science model without a purpose, and I'm not going to do this visualization without a purpose. And then finally, to me, this really was the nut to crack. I mean, you see it over and over again in all the explorations I've done where I needed this piece for it to at least start to make sense. So, you know, I took it from kind of an aggregated view down to an individual view.
This, coincidentally, this was my favorite part. This part on the right, the recommendations rationale. Yeah.
And it was essential for me. Like we went round and round about it, but it was one of these, I can't do this without this. I can't see it without this. Like this alone is not enough, because what this says is you don't trust me as an end user. Whereas I need to at least see, okay, this is kind of how it made its decision. You know, so in international minutes, I can see here's some of these other items, but look how high up international minutes are. Day minutes are high, but those international minutes get weighted heavily. So I can at least start to make sense of these things. And that, I needed that. And I know, you know, as you roll these things out, I don't trust a machine. I bought a fancy car and it does automatic braking, but I still don't trust it. I brake on my own.
Okay, well, I know we're going to probably have some questions that are going to come up, but let me ask one more of kind of both of us, and I'll, if you don't mind answering first, I'll let you answer first. But I would imagine there's some sense in which people are going, man, I just don't know how to get going on something like this. Like, I'm inspired. This is great. Bridget, the stuff you're doing is just phenomenal. What's my next step? I mean, because I think those could engage those could go all the way from just hire someone like us to do these types of things for you, all the way down to here are some resources to help you further your own education to be able to build things like this. And so thinking about running the gambit, what kind of recommendations would you make to people that are going, I want to do things like this. I want to be this type of person for my organization.
So particularly from a standpoint of visualizing data science, so going into kind of communication, but also communication centered around data science, I read a lot. I read on Twitter. I follow various people who are doing the kind of work I want to do. So it's one of those find your heroes so that you can model them, so that you can see things that they've done. The other thing is, don't be afraid to fail. I mean, that was probably the biggest piece. It was the most complicated one we could choose. I failed a lot, and I failed intentionally. I tried to fail as quickly as I could. And so that was probably the other big piece, was failing frequently and failing fast and failing often, so that we could say, okay, well, it's not these things. So what is it? What are we trying to get to? And so sometimes getting to a no, it's just as important getting to a yes, because you know what you don't want. And as you start to say, okay, these things are not it, these are the things I want, it really narrows your focus to the things that are most valuable. So you can say, okay, well, viewing this data at a high level really didn't do it. Viewing the data at a low level provided some further clarity.
I think that's great. I love the idea of finding your heroes and reading them a lot. I'm going to kind of answer the question I want to answer. So I'm going to rephrase that same question that I asked of you. And kind of what do you do though if you know you need to be doing kind of more this quant data science and then the visualization on the background, but you don't have access to a quant person? I think that's one of those things where there are a couple options. There is the option of you can engage someone like us to come in and kind of help you with that, and then you're building the visualizations around that. And we help mentor you through that. But I will say this too: there are technologies that are advancing incredibly fast. So Data Robot, and this is a good example of this. Data Robot is an example of a very high level quant statistics-based platform that is easy to use for somebody who doesn't have a degree in statistics or even a degree in data science or something like that. It's very easy to use. Alteryx is going the same route, and that they are starting to put a kind of a machine learning piece inside of Alteryx, and so in order to build models, and then you build your visualizations based on those. And I will say too, even Tableau, since being acquired by Salesforce has now launched something called Einstein Analytics that will do machine learning stuff for people who don't have a degree in math or stats. Okay, so it's one of those things where now the level of resources available to you are actually really, really good. Whereas even just 3 years ago, we wouldn't be having this conversation. It would be, hey, you've got to hire a statistician, and by the way, they're going to be really expensive. But now things like Data Robot, Einstein Analytics, Alteryx, they're making these types of routines available to a person without that advanced degree or that advanced training.
I do want to jump in on that real quick. And I also want to say, where possible, don't do these things alone. And it's not just, okay, hey, go find somebody quanti, but the other thing is, go find people affected by this data and make sure that you're also mitigating harm. And that would be probably the one thing I would throw into that is, tools like Data Robot make this fantastically easy, but you still want to franken-check your work and make sure that you're not making a horrible assumption.
That's a great point. Great point. Because there are, I mean, they aren't, you're right, they aren't foolproof, right? Data Robot will give you the best model that it came up with, but it could still be crap. and so you wouldn't know necessarily. I mean, it's going, well, hey, here's the model that wins out of all the models we tested, but it's still terrible.
Based on the data inputted. But if
yeah, exactly right. Because the model's true, you just may not have any good data. Yeah.
And you got to know what you're putting into it. So, I mean, something like this, you know, fairly straightforward, you know what you're putting into it. Some of these items, particularly when you get into things like zip code and things like that, there may be data hidden within your data. So it's always good to really go through and seek non-technical expertise, but those affected by the data to understand what could go wrong, particularly
Absolutely.
when you're getting into something like predictive analytics.
Perfect. So it looks like we have a few minutes left. Rachel, would this be a good time to kind of open it to questions?
Yes, so feel free to post your questions using the Q&A panel on your Zoom. It can be located at the bottom right. One question that came up just now is, how do you turn on captioning CC?
Closed captioning?
Yes.
I'm not sure if that's a Zoom specific question.
I have no idea how to do it in Zoom.
Linda, if you can provide more context around that, we'd be happy to answer.
Yeah.
Another question is for data science ML. It'll be an iterative process. Hang on, it's a long question. What would be better visualization process for keeping this iterative process seamless to track and understand better? Is it like a boilerplate viz and reuse some of it, or something different?
That's a really good question. So I'll start with that, and then Bridget, if you want to follow up. There is this the one that Bridget's built will only work as a boilerplate if you have another categorical model, meaning that you're trying to predict something that's categorical and it has 5 outcomes. Okay, so the visualization that has been built here is actually really specific. I think it might be hard to say, all right, we've now had this boilerplate viz that we're able to use with all categorical, or a boilerplate viz that we're able to use with this. And the reason I bring that up is because, remember, Bridget built a viz so that we could build a viz, right? And that's the key to all of this. And so I don't know that I would feel really good about a boilerplate. Bridget, do you have comments on that?
I definitely have comments on it, and I would say particularly when you're presenting data science, boilerplate really gets dangerous because it could present something, you know, a lot of this is designed around intentionality. What are we trying to communicate? And so, you know, for example, this is very, very high register terminology, standard deviation, model precision, and confusion matrix. All of these are terms I wouldn't want to reuse out in the general public. And so I ended up customizing my message towards, you know, whom is likely to see this. So instead of it being, you know, a lot of features and factors and this and that, you see I have recommended rationale. You know, and so that worked in this context. I definitely think it's good to use inspiration. I think it's really key to look at how did other people present this? Can I use this for my specific problem? You know, so one example is here's kind of this weightings, and you can really see like what's the likelihood. If a lot of data is stacked on one, I mean, you can really see that there's definitely some limitations with this, you know, and so some inclination is, hey, we could do a stacked bar chart. I wouldn't recommend things like that just because it didn't really fit with the intention. And so I think the key to this is really understanding your intention. So when you do a data science problem, there's a goal. You're trying to get a result. And so that's where I feel like any type of boilerplate is going to detract away from the result you're trying to get. With this, you know, we're trying to get offers. And so the whole thing is built semantically so that as you start offering things, all the colors really support. So I've got daytime plan. You see this yellow really calls attention. All this yellow flows through the entire viz. So that won't necessarily work well depending on another thing. And if you put too many items in, it really does get overwhelming.
Awesome. We have another question around how effective is Data Robot at spatial analytics?
How about it's getting better every day? So that's a great question. I don't think that is a necessarily I mean, if I'm doing spatial analytics, I'm probably going to stay in Alteryx. Like I really like Alteryx for spatial analytics. Data Robot starting to move now, depending on what type of spatial analytics you're doing. Then Data Robot does have some options. I will say that I don't know for certain if this is a plan in the future, but I do know they are starting to incorporate some really cool aspects, like you can do analytics around pictures. And so I know one of their newest work sessions that I was in, they were showing us how predicting the house price value, they're actually able to pull information from pictures that are on Zillow. And so that can do things like, analyze a kitchen picture and determine, hey, is this a, built-in stove versus a standalone? And, how does that affect price and things like that? Really, actually really impressive. So if I am just doing spatial, I'm probably going to stay in Alteryx for right now, though.
Great. Well, I think that's all the time we have for questions today. I just wanted to say real quick, Bridget, Kyle, is there any final thoughts you'd like to share before we close up?
For me, nothing other than say, if y'all are interested in more, we'd love to engage with y'all, or if we can help you become an advocate where where you're working for this type of analytics, let us know. We'd love to partner with you on that front. Bridget?
I think you wrapped it up nicely. Thank you.
Great. Well, thank you so much, Bridget and Kyle, for your time today and an awesome presentation. A reminder that today's webinar was recorded, and the recording, as well as other additional materials, will be emailed out to you, if not today, then tomorrow. So thank you so much for joining us today. We hope to see you next time.